we will do line tracing, but let us check first the code, the initial code. So we have the program definition, just a short info about the program or the sketch, and then the declarations. I have declared all the pins I need. So you have the LED speaker, the left and right line trackers, and the pins for the left and right motors. And for the setup, I have specified that the LED speaker our output line trackers are output including, so that would be the left and right line trackers. The pin for the left and right motors are output. And currently the loop function is empty. And these are the functions for the LED. This is for blink. For the speaker, this is for beep. This is to check for the value of the left line tracker, right tracker for the distance. This is to control the left motor. This is for the right motor. This is to stop both motors. This is to make the robot move forward by setting both motors to move forward. Reverse, left. The left and right functions or left and right motor functions. I also included a time duration. So this function will make the robot move or turn to the left and stop after a specific number of milliseconds. Same with right. And let's start. So the idea is I have the line here. This line here or the guide will be wider since we only have two line trackers or two sensors, and we'll make sure that the robot will have a higher probability of seeing the line by making it wider. And of course, I have to make changes to the position of the line trackers, move them further to the left and right, because the original setup is this. So I made changes since our path is wider. I'm using a 9-volt battery. And the robot has no code uploaded, so it's empty. It's not gonna do anything. So let's check. We're supposed to make sure that the robot stays on the line, and that can happen if we will write a code that makes sure that the robot will adjust accordingly. So if the robot, so this is the left and right line tracker. If the robot moves this way and the left line tracker sees that it's on a black line, it should move or turn left until the left line tracker is off the black line. So same thing with the right line tracker. If the robot moves this way and encounters the black line on the right line tracker, it should move or turn right until such time is no longer on top of the black line. So that should happen while the robot is moving forward. So the robot should move forward and make changes accordingly, making sure that it stays on the line. And also, we'll have to double check if there is an obstruction in front of the robot, it should also stop. Okay, so let's I'll connect the robot to the computer. Let's work on the code here. So first things first, I'm using a 9-volt battery, and here I'll use forward 40% power. Let's look at the code. Here it says here forward 40, and forwards the value of power, which is 40, to set left and set right motor, which converts it to a value from 0 to 255, because 255 is actually 100% and 0 is 0%, and we're using 40% because 40% of the 9-volt battery is around 2.6 volts, because our motor is rated 3 to 6 volts. So it should run or start running or turning at 3 volts, and we make sure that the power does not go beyond 6 volts. Alright, so let's go back. So it should move forward, and let's check. I'll use while. I can use if, but I want to use while so that it will stay in the structure as long as the condition is true. So I want to check if the distance, so we have the distance function. The trigger is connected to pin number 2 and the echo is connected to pin number 4. And if it's less than 10, so I'm talking about centimeters here. So if it's 10 centimeters less, then I want it to stop. So as long as the distance is less than 10 centimeters, it should stay here and say stop. I can even make it blink or 50 milliseconds, and also beep for 10 milliseconds. So it will keep on blinking, and wait, it's like 255 maximum power or 5 volts, then it should be for 10 milliseconds and then stop. So all three things will be happening while the distance is less than 10. And then, so this is to check if there's an obstruction. Check for obstruction, making sure the robot will stop if there is something in front of it. Then I'll check for the left line tracker. So while left tracker, if the left tracker will return 1, as long as it's 1, it will adjust. It will, or it should move to the left or turn to the left. So left, let's say 35%. So that's that's more or less around 3 volts, less than 3.6 volts, and then I'll just put 1 millisecond because I don't want it to move that much, because it should rely on the value being reported by the left hand. So 1 millisecond is okay, not that much. And then also I wanted to check the right line tracker. If it's 1, then it should move or adjust to the right. So this is to check the check path, okay? Or check the line. So it will do three things. It will move forward, it will check for obstruction and stop if there is, and then check the path by checking the left and right path and make adjustments accordingly. So I'm going to upload. Let's check first the connection. Okay. So again, if this doesn't work, the old bootloader, select the explain 80 megas to 8P. So I'm going to upload. Wrong spelling there. So again, done uploading. Let's check. Oops. Let me just double check the there. So the robot is currently making adjustments and stops whenever there is an obstruction. Let me just check the placement of the setting. Let me test again. And it should stop. There you go. Let's make it move the other way. And all you need to do on your end is to check if this code works and make adjustments, because it may be different on your robot because of your power supply. I'm using a 9-volt battery. This is a rechargeable one. If you're using a different power pack or a power supply, you have to make adjustments to the amount of power that you give to the robot. And that's it for now.